Good afternoon. Thank you to all joining us today. So the seminar today will focus on the Flint water crisis, and we have three speakers who have worked directly with local communities in Flint to uncover the causes and consequences of the Flint water crisis. So we'll be joined by Dr. Victoria Morckel from Michigan State University, Dr. Sadler, also from Michigan State University, and Dr. Sid Roy, who is a research associate at the University of North Carolina Water Institute. Just a kind reminder that we will first have the three presentations, and we will then have a Q&A at the end. So our first speaker is Dr. Morckel, who is a member of the urban planning faculty at Michigan State University. So I asked Vicky to provide a short introduction to the Flint water crisis, just because we're based in the UK, and for the audience to have an introduction of what happened. And Vicky will then present her work on the causes and consequences of the Flint water crisis, explored through an urban planning lens. Vicky, if you can start your presentation. Yes.
All right, excellent. Okay, so my presentation today is titled The Flint Water Crisis from an Urban Planner's Perspective, Causes and Consequences of a Water Contamination Event. So as Maria noted, I'm an urban planner, so I perhaps view the crisis from a different perspective. I don't consider myself to be a disaster planner, although that's certainly a subfield within our profession. I sort of fell into the water crisis work by accident, by being in Flint at the time of the crisis, but I'll return to that in a moment here. So today I'm going to give a brief background on the water crisis. I'm also going to present some main points from my paper titled Why the Flint, Michigan, USA Water Crisis is an Urban Planning Failure. So that starts to get at some of the causes of the crisis. That was published in Cities, if anyone's interested in checking it out. And then I'll talk about what I'm calling the secondary effects of the water crisis. So these are consequences of the crisis that extend potentially beyond public health and beyond issues of water quality. So I tend to view this from a perspective of an urban planner that looks at issues of urban decline. I really specialize in cities that are facing population loss, thinking about issues of community development and quality of life in cities like Flint that have faced significant population loss. At the time of the crisis, I was working at the Flint campus of the University of Michigan. I live just south of the city. My kids attend school in the city. So I am rather local, perhaps not as local as Rick is, but nonetheless, I'm very familiar with Flint. I also was fairly involved in the city's master planning efforts when it redid its master plan around 2012. So as I noted, Flint is a city that's lost significant population. At its peak, it was about 200,000 residents. Around the time of the water crisis, it was approximately 100,000 residents. Today, estimates put the population at around 80,000 residents. So likewise, the city is and was in severe fiscal distress. You have a city with infrastructure built for 200,000, and yet there's half or less than half of the population to be able to afford those services. So a large number of infrastructure and services, but fewer people to pay for them in way of like income taxes or property taxes. So in April 2014, to save money, the city switched from getting its water from the city of Detroit, which draws water from Lake Huron, to the Flint River. This was done as a cost savings measure, awaiting connection to a new water authority. But the river water has a lower pH, it's more acidic than the lake water. And unfortunately, the city did not add corrosion control chemicals to the water, which resulted in lead and other metals leaching from the city's aging pipes. So I think Sid might talk more about this later. So pretty much right away, residents voiced concerns about the switch to the river water. The tap water was severely discolored. I saw that in Flint as well, where you could turn on a tap in some campus buildings and the water would come out orange. So visually, there was certainly a problem there. The residents were also expressing concerns about health around the time of the switch, and really complaints continued for over a year, but the city and others had assured residents that the water was safe, which of course we found out later that that was not the case. In fall 2014, a local pediatrician found elevated blood lead levels in children. Around the same time, there were tests conducted by Virginia Tech, their research team, also demonstrating high levels of lead in the water. The city of Flint declared a local emergency, state of emergency in December of 2015, with a federal state of emergency being declared shortly thereafter. Pipe replacements have been ongoing, so that's unfortunately taken a very long time. At this point, there's less than about 5% remaining. So that's almost completed, but granted, pipe replacement started in 2016. So I'll note that I don't view the crisis necessarily from a who did what perspective, as far as individual actors, as far as like who did or did not decide to add corrosion control chemicals. Instead, I view the crisis from a long range, or what you might call 30,000-foot perspective, thinking about how did we get to this point, that the water crisis was really an event that was decades in the making. So I should have noted, when we're talking about the crisis, we're talking about a human-made disaster that likely expose tens of thousands of people to lead and other metals over the course of a year. So pretty dramatic. So anyway, I'm looking at the crisis from a structural or a societal perspective, thinking about it from the perspective of problems that depopulating cities like Flint face. So Flint is not the only shrinking city in the US. It's not the only one facing challenges with paying for and maintaining infrastructure. And again, looking at it from that perspective, that broader perspective that urban planners often take. So one of the potential causes of the water crisis, of course, is the population loss, that infrastructure is not being maintained because the city doesn't have the funds to do that. And due to fiscal distress, the city had reason to try to save money and change water sources. So really, this is an inability of the city to be able to address the consequences of population loss, not unique to just Flint, that Flint has lost more than 70,000 General Motors jobs, so automotive jobs, since its peak. So we're looking at structural change in terms of globalization, also considering the effects of suburban sprawl. So over time, primarily middle-class white residents have left the city for nearby suburban communities, and therefore have left behind, in some respects, a poorer, more minority population. So likewise, we see greater demand for services. You know, we would have a greater demand, say, for public transportation, for example, but at the same time, services are less efficient because we have a population that is spread out across a larger physical area, and that likewise costs more money. In general, growth-oriented solutions haven't really worked. Flint has tried many, you might say, touristy types of ideas. Granted, the downtown of Flint is seeing some revitalization, although I would argue that the improvements to the downtown are eclipsed by the decline that we see in neighborhoods elsewhere in the city. Likewise, it raises questions about whether we should rethink infrastructure in the city, whether we should consider the phrase that's often used as right sizing, whether we should consider ways to sort of de-urbanize the city. An example would be doing something like a road diet. So instead of having a road that's 4 lanes, maybe you no longer need 4 lanes because population has declined, and 2 lanes would therefore serve the purpose. So we're matching the size of the infrastructure to the size of the population. You could also do things like when a property is demolished, instead of continuing to mow a vacant lot at public expense, oftentimes you might think about returning that property to nature, particularly if it's, say, adjacent to existing park space. But nonetheless, when we do think about these types of strategies, there's a lot of serious questions about, say, social equity, social justice, that are you removing services from populations that are the most vulnerable? And that, of course, would not be desirable. There's also questions as to whether there's real cost savings in thinking about these sort of degrowth or deurbanization models. Secondly, arguably, the Flint water crisis is caused by Flint's inability to engage in regional planning, which is not unique to Flint. In the US, we tend to be very insular. We have a fragmented political system. Communities have a lot of autonomy. They oftentimes compete with neighboring communities. So one argument is, if you can't right size, or you don't want to right size, then you need to make the city's budget large enough to continue to provide the same level of services despite population loss. And you can't do this by just endlessly raising taxes within the city. That you have a poor population, they can only pay so much in taxes. If you're raising taxes, you're also making an environment that might be inhospitable to attracting businesses, for example. So that's not necessarily the direction to go. Instead, possibly Flint could have thought about annexing the suburbs, although many suburban communities had incorporated to try to prevent annexation. Maybe you could have thought about a growth boundary, but politically those tend not to be very palatable in the US. Strategies to encourage infill development would certainly help. I would argue that the region needs something like regional tax sharing, regional governance, that really, to assist the city of Flint, you need to be able to pull in resources from outside of the city of Flint. But politically, that's very, very difficult to do. Regional governance was considered in the 1950s. That failed miserably because suburban residents were not interested in that. I'll also note that the county population, so that's like the next size political unit in some respects, has not really changed. It's been roughly stable around 400,000 residents. So we've had a landscape where we've continued to build new roads and new houses in suburban communities, which helps to contribute to issues like vacancy and blight in the city of Flint. Because if you have the same number of people and you've built more stuff and people are more spread out, then you're going to end up with fiscal distress in the oldest, or what some people might deem to be least desirable community within that particular geography. And then third, I would argue that the crisis is, in part, it stems from us, as you might say, Americans, being reactive and not proactive when it comes to maintaining infrastructure, especially when we're talking about water infrastructure, that it's largely out of sight, out of mind. You don't see it. You take for granted that you turn on the tap and water comes out and it's fresh, and you go about your business and you don't think about it. Nonetheless, the city of Flint knew that it had an aging water system, but due to the aforementioned fiscal issues, it couldn't really do anything about it. So I will read the quote here. This is from the city's master plan. It says, much of the piping in the water system is over 70 years old, and a significant amount of the 48-inch mains are prone to breaks and unable to provide modern pressures and fire flows. According to a 2011 water reliability study, the distribution and transmission system is old and in serious need of replacement. So the master plan, again, was adopted shortly before the change in water sources. So the city was aware that there was old infrastructure. Arguably, you don't have a water crisis, or you don't have a crisis at this level, if you don't have old lead pipes. So again, thinking about how do we be more proactive about replacing infrastructure, particularly in older American cities that oftentimes are facing fiscal distress. So does it take state intervention? Does it take federal intervention? And how do we think beyond city, specifically the city of Flint, to other US cities and beyond? And then as far as secondary effects, some of my work has considered the effects of the water crisis on the housing market, the effects of the crisis potentially on population dynamics, so whether people are moving out of the city and whether that's contributing to property vacancy within the city, and also resident trust in government. So I'll highlight some points from the housing study. I may talk about trust in government if we have time. So nonetheless, much of this comes from a survey that my research team had conducted in summer of 2016. So this is the height of the crisis. This is during the federal state of emergency. So this is a survey about 300 homeowners, and we asked people Likert items, so how strongly they agree with statements like, I am concerned about the effects of the water crisis on my property values. I would like to move out of the city of Flint, but I cannot financially do so because I cannot sell my home. Generally in the US, people need to sell their home to be able to buy the next home because you have home equity that then serves as the down payment on the next home. And then I've considered abandoning my home, which means not selling it, leaving it vacant, just walking away, so that I can get out of the city of Flint. And as you might imagine, most homeowners were concerned about their property values. The longer they thought the crisis would continue, the more concerned they were about the property values. So we did ask people, like, how long do you think this is going to continue? We also found that more than half of homeowners said they'd like to leave the city, but they didn't think they could sell their homes. So the water crisis, of course, attracted national and international media. When you ask people, do you want to move to Flint? Well, it makes sense that people would say, well, no, I'm not going to move to a city that can't provide fresh water and basic services. We also found that the lower respondents' income was, the more they indicated that they were unable to move, which inherently makes sense. We also found that 20% of homeowners had considering just walking away, just abandoning their homes to get out of the city. We found that people with children were more likely to abandon. People who thought the crisis would go on for a long time were more likely to abandon, or at least think about abandoning. And the longer that people had lived in Flint, the less likely they were to consider abandoning their home. So largely we consider that to be perception of housing market change, or perception of constrained mobility, whereas then we thought, well, let's look at whether there's a real effect, so-called real effect. So we pulled data from an entity called Policy Map. We also looked at home mortgage data that's reported to the federal government, and looked at changes in sale prices and mortgage origination values over time. So I'll note that in shrinking cities, cash sales oftentimes equate to property speculation. It's people that are buying cheap properties and oftentimes not maintaining them, not putting any money into them, but renting them out until they have so many code violations that they can no longer rent it out. So it's a form of speculative investment. Also, mortgage originations likewise oftentimes equate to healthy market activity. So we considered the peak crisis in terms of the housing market as the years 2016 and 2017, in large part because public awareness of the crisis really didn't occur until late 2015. So if you're looking at a housing market effect, it would need to be after that. So we looked at citywide trends from before and after the crisis. After, in quotes, some people would consider that to still be ongoing, but nonetheless, 2012 to 2017. We also looked at maps of change over time, so spatial aspects of this, which I'm not showing today, and also considering inferential statistics. Do prices and values change or differ at the census tract level over time? So census tract is the political unit. I don't recall the number of tracts within the city offhand. I want to say about 40. You're looking at approximately 1,000 to 2,000 housing units per census tract to have some sense of scale. Excuse me. Okay, so this is just a snapshot of citywide trends. We found that less than 20% of sales in a given year have a mortgage, which points to a very weak housing market, which we were already aware of. The state average is, I think, 56%. Other states have an even higher percentage than that. So prices are so low that one doesn't need a mortgage. However, we generally find that it's not owner occupants who are making cash purchases. We're looking at a city that has, depending on the year, a greater than 40% poverty rate. So it's not residents who are buying up these properties. I also want to note that values that are this low, so if you look at median sale price, this is in US dollars, you're looking at approximately $15,000. When values are this low, it actually depresses demand rather than increases it, because you'll purchase a property, you'll put a lot of money into it, but then you can't necessarily sell for a price that allows you to make a profit. So $15,000, that's like about the price of a car. So that gives you some sense of what we're looking at. So, and my timer beeps, so I will give you some punchlines, you might say. So we do not find differences in median sales prices over time. We do not find differences in mortgage origination values by year. So you might say there's no effect of the crisis. However, in part it's because there was a very weak housing market before the crisis. So in some respects, there's really, nowhere to go, like it can only go so low, so to speak. It also supports other studies that demonstrate environmental crises have greater negative impacts on stronger housing markets. We also have some concerns about constrained mobility of residents that I didn't get to fully flesh out, that because the housing market is so weak, whether or not that's caused by the water crisis, you have residents who are vulnerable, who may want to move, who cannot move. So there's some issues regarding social equity as well. And then I think I'll end on this point. So some of the results of this paper, which again, I couldn't really fully flesh out in 20 minutes, and another manuscript as well, suggest that as water infrastructure quality deteriorates, population loss could accelerate, which results in what we might say is a recursive relationship. So this is like saying quality of services and infrastructure has declined, people leave because of that. Because people have left and the city has even more fiscal distress and even more vacant homes, more people leave. And then because more people have left, the quality of infrastructure and services further declines. So then more people leave, et cetera, et cetera. So you get into this vicious cycle whereby it's like one disaster or problem leads to another. And this becomes very difficult to break, especially if you don't have outside resources. So again, my data ends in the year 2017. This is not to say that we don't have additional effects of the crisis on the housing market beyond that. That certainly, it wouldn't encourage people to move into the city. So it may be that my data set was too soon. And if I were to repeat the study again, I would get different results. So I will stop there for sake of time. I thank you for your kind attention, and I'm happy to take questions at the end.
Thank you, Vicky. So our next speaker is Dr. Richard Sadler, who is a geographer and also an assistant professor at the Public Health Division at Michigan State University.
Yeah, thank you. And thanks, Victoria, for kicking us off. That was great. So, I mean, I think perhaps as you might expect, since Victoria and I both have, we're both in the world of geography and planning, there's going to be a little bit of overlap, but I don't think there's going to be a whole lot. And I'm going to be sharing a lot of results from a paper I wrote with a few colleagues about a year and a half after the explosion of media interest into the water crisis. But yeah, so thank you again for the opportunity to speak with you. I've been at Michigan State since 2015. I'm now an associate professor in our newly minted Department of Public Health. So we've grown enough that we've become our own tenure granting full-fledged department. So I'm part of MSU, but I'm in a research unit here in Flint. I also grew up here during the 1990s. Deindustrialization was already well underway. And I certainly saw some of that, although I didn't grow up in a neighborhood that had high vacancy rates. So I kind of saw that vicariously. I very much share Victoria's view that the crisis had long-term structural determinants. And I'll share a couple of other kind of related but slightly distinct thoughts to that effect in my slides. I did want to acknowledge a number of my collaborators. I'm a medical geographer by training, but pretty much all of my work on the water crisis has been collaborative. And since all of you on here today come from so many different disciplines, I wanted to share that my network is likewise diverse. So I've worked with pediatricians, historians, engineers, statisticians, epidemiologists, and also community partners. And actually a couple of community partners who are also academics who incidentally went to high school together here in Flint. That's Deborah and Dane there. So I wanted to start with a few comments on Flint's history, kind of to build on what Victoria was talking about. So I grew up hearing from my parents about, and my grandparents about, oh, Flint's heyday and how great the city was. And, there's all these General Motors jobs. But I also came to learn a little bit from them, but more from kind of being in the academic space about Flint's issues, right? About the proposal to create New Flint and how that was rejected by suburban voters in 1958. Because even then, the suburbs didn't want to be a part of the city. How Flint lacked economic diversity that made it particularly vulnerable. So this graph here showing Flint as the literal poster child for cities that lack economic diversity. How redlining and racial exclusion basically pinned the predominantly African American neighborhoods in next to the factories, and then also made them prime candidates for urban renewal and displacement by way of freeway construction. So a lot of that social and political history that all built up these precursors to the water crisis. And so after the kind of the onset of media attention, I reached out to a local historian who's at UC Irvine, the University of California, Irvine. He'd written a book on decline in the city of Flint, and we collaborated on a paper that kind of tied some of these things together. Of course, it's also important to note the more proximate causes, namely the formerly gerrymandered Michigan legislature. So we had a legislature that really didn't represent the voice of Michigan residents. They passed a policy in 2003 that took away revenue sharing, which caused Flint to lose out on approximately $55 million during the time period leading up to the water crisis. And I like to share this because it's kind of sad that Flint's deficit when the state took them over, which was one of the more proximate precursors to the water source change, was actually less, even with their bond indebtedness, less than they would have had if that revenue sharing agreement had just remained in place and Flint had been able to use state funds to support some of its finances. It's also important to note that Michigan had an emergency manager law that we actually voted out in 2011, and that the Michigan legislature undemocratically put back into effect and tied it to a budget line so that voters couldn't overturn it with a ballot initiative. And then it's also important to note most municipalities that were taken over by this law have been predominantly Black. And so, it's sad, right? But this kind of behavior is becoming a baked-in trait of the American Republican Party over the last several decades. So it's something that Michigan has had to deal with in terms of how do we respond to a financial crisis in a city? Well, the outcome has been to punish these cities, right? To just cut and cut and cut. And like Victoria was saying, like a potential solution would be actually to just find new streams of revenue, help these cities grow back. But the state has really not been interested in doing that. So I mentioned my work on the water crisis started in earnest kind of before that. And so I worked with Dr. Monahena Tisha on one of their first papers. The Hurley Medical Center put this paper out. So she'd held a press conference sharing her preliminary analyses of pediatric blood lead levels, and shortly thereafter looped me in to be a part of the broader team mapping these blood lead levels. And that's what this map is showing, is a an interpolated or predicted surface, like a projected surface of basically what kinds of blood levels you would find in each neighborhood. And we use this to illustrate, it was more a communication tool. This particular map was because, again, it's predicted levels. We don't have any of the individual data visible in this. But one thing we did is we linked up the ward level water lead levels that Mark Edwards' lab at Virginia Tech had found in their work over that spring and summer. And basically we're able to show some of that first evidence linking blood lead levels to water lead levels. And so I also like sharing, as a geographer in particular, this is an example of the modifiable aerial unit problem some of you may be familiar with. But our work was necessary because the state was mischaracterizing lead exposure boundaries. Initially, they had been measuring lead exposure by our postal codes, which are shown in blue, but the city of Flint is the green shaded area in the middle there. So they were basically overbounding the city and putting a bunch of kids into the sample that weren't actually living in the city of Flint and therefore weren't being exposed to that water. So that was a piece of the puzzle that I helped to uncover. So it's about a third of Flint addresses were being lumped in there. So we then followed up with a paper where we looked at some of the built environmental factors that may correlate to higher blood lead levels. And this table is kind of showing the results, but just to summarize it, we basically found that the highest predicted blood lead levels were in neighborhoods where water had been resident in the pipes for the longest, where houses were the oldest, and where the neighborhoods overall were in the poorest condition. So we have some older neighborhoods, but they're still really well kept. And those neighborhoods were not as affected as neighborhoods maybe even that are a little younger, but that were really falling apart and where there's, other infrastructure issues. I also note as an aside, although this is very much a case of structural racism writ large, within the city, residents, whether they're white or black, had about the same odds of experiencing elevated blood lead levels, at least during that time period. So again, it's not to, overall, because Flint is a predominantly African-American city, it is a case of structural racism, absolutely. But within the city, whether a neighborhood was predominantly white or predominantly black, that wasn't one of the big predictors in this case. Okay, so in a later study that's going to be the focus of the balance of my talk, I worked with my colleagues from Wayne State and Colorado State to more intensively study the association between blood lead levels and the Flint water crisis. So we modeled blood lead outcomes in two ways to verify the impact that the water crisis had on blood lead levels. And in this case, we modeled 4 time periods. And so 3 of what we call regime changes. So we use difference and differences analysis to compare Flint kids to kids outside of Flint from one time period to another in 3 different kind of slices that I'll illustrate. So that's what we call the 4 phases of the Flint water crisis paper. So they take us, the first phase takes us up to the point where the state changed the city's water in April 2014. And then the second phase takes us from that point up until the first issuance of boil advisories. And I do want to note, of course, I'm going to talk a little bit about boil advisories. Boiling water doesn't take lead out, but what we presumed in this paper is that the water avoidance behaviors that people undertook when they learned that they should be boiling their water, it spooked people. They may have potentially stopped consuming as much water at that time and therefore been exposed to less lead by way of the water. So that's why I'm talking about boil advisories, but just to note, of course, boiling actually makes lead in water worse, is my understanding. So then the third phase takes place from after the boil advisories took effect, but before the switch back to Detroit water. And then there's a 4th phase that takes place in the time after the switch back to Detroit water. And so these 3 regime changes are phase 1 to phase 2, which is we compare the blood lead levels of kids before the switch and then after the switch up until the boil advisories. So basically before there was any kind of local response in those first few months when, maybe residents had started noticing things, but there wasn't a lot of focus on the water system yet. And then we compare phase 2 to 3. So both of those periods are after the water source change, but one is before those boil advisories took effect and one is after. And then we also compare the totally before period to the totally after period. So before the water was changed to the river, and then after it was changed back to the river, basically to show was there a return to normal. Doesn't mean normal is good, right? But a return to normal after the water is returned back. So like I said, we use difference and differences to identify the effects of these regime changes. We have a period indicator, meaning the time period, and a spatial indicator, meaning Flint or not Flint. And I know perhaps you all are not necessarily statisticians. I'm not either. Some of this language I got from my colleagues, so just so you know, I'm not going to get like super technical in this, even though there are going to be some kind of mathy looking things on the next slide. So basically, we used logistic regression to model the probability of a child having elevated blood lead level at any given time. And then we used generalized least squares regression to model blood lead levels over these same time periods. And then we used the coefficient delta down here to capture the potential effects of the regime switch on the interaction of so F and P. So again, whether a kid lives in Flint or not, and period, what the time period is. So logistic regression, generalized least squares regression are the two basic things to take out of this. And so the results here, when we compare before the switch to after the switch, but before the boil advisories, we did find a significant effect. Basically corroborates the work that that my colleague Monahan Tish and I did. And so the change in micrograms per deciliter is about 0.45 in the blood lead level model, that's shown here. And then the odds ratio of getting elevated blood lead, basically there's an odds of 2.38 when you compare before and after among Flint kids. When we compare before and after the boil water advisories, they decreased blood lead levels of children, but not significantly. So of course, take that with a grain of salt. It's not, there seems to be some kind of movement downward, but they're not significantly different. But there is a lower odds ratio in the after model. And then when we compare totally before to totally after, basically we found that those blood lead levels were more or less the same. So again, this is giving a little bit of evidence that after the water source was switched back, there was some return in terms of lead exposure. Again, I'm not saying that there weren't other ongoing effects or that other things weren't going on in the water system. And certainly it did all kinds of things during that water source change. It did all kinds of damage to kids that we're, of course, still studying. But that's just to say that the lead exposure itself returns to what it had been. We also looked at a temporal view of this impact, and just to kind of give you another view into this dynamic, that elevated blood lead levels began about 60 days after the water source switch. So for 2 months, the pipes were still okay-ish, and then after that time, there's the significant departure from the baseline level. So that's what this line is here, and once that gray emerges over top of that, there's a significant signal. And then it also suggests that for about 2 months, there was, before the boil advisories, there was 2 months where people weren't necessarily aware that there was an issue. Again, over and above perhaps what residents may have been experiencing themselves. So just to summarize those, the switch itself caused higher blood lead levels and more elevated blood lead levels. The boil advisories were tied to an insignificant decline, but there might be something there. There could be something with that. And then switching back to Detroit Water returned blood lead levels and the risk of EBLL to pre-switch levels. And then as I close, I do want to illustrate that Flint is still very much at risk from other built environment related issues. Our city is still one of the poorest in the nation, and our sprawling and fragmented region that we're left with, as Victoria said, it makes it hard to come up with any kind of land use related solution. We can't just consolidate our county, and even if we did, we'd have to deal with all this extra infrastructure that our suburbs have built over the last 70 years. So our region is weaker, right? Our municipalities are fighting with one another for investment or wasting money on needless infrastructure. So I did this study. So Flint is here. And again, it's one of the poster children for the most sprawling and fragmented and unequal cities. And we did this study to identify other maybe peer cities that are struggling from these same kinds of land use issues. And we found pretty strong relations between these and economic vulnerability overall, in particular in the American Northeast and Midwest. Again, as Victoria mentioned, nearly all of our lead pipes have been replaced. I can also share that our city public health office is devising a strategy to reach out to those holdouts. So we're looking at where those folks are, what kinds of neighborhoods they might be in, and trying to figure out some kind of targeted outreach for, hey, why is it that you don't want to have your pipes replaced? What can we do to accommodate that? I think Victoria might have mentioned this, but we also passed a new zoning code. And a lot of that, what that zoning code does is it changes the zoning pattern for a big chunk of the city that is very heavily depopulated, which could in time help the city manage its infrastructure. It doesn't promote new development in green neighborhoods, high vacancy neighborhoods. And so we could start eventually doing some of those things, those kind of practices around right sizing our infrastructure. And then really just a thought that I think I share with Victoria, that the future land use planning decisions really need to, they weigh our social impacts, not repeating the past around urban renewal, and also though kind of a side thought, making allowances for future growth, especially in a climate change induced future. There's been a lot of articles recently that while climate impacts could be uneven, the Great Lakes region could wind up being a net receiver of populations moving away from other parts of the US and other places. And so just to bring it together in closing, I want to emphasize that the processes at work in Flint over many decades caused the water crisis and continue to influence its trajectory. And all of these elements, housing, infrastructure, education, they all correlate to how well a city functions. And human constructed crises like the Flint Water Crisis will happen again if we don't commit to reinvestment of our cities. So ultimately, it's easier said than done, but we just need to build better cities if we want to get at the root of health disparities. And that's a lot of the work that I do in public health here. So I'll leave you with that and a couple of ways to reach me as we transition. Thanks.
Thank you, Dr. Sadler. And our last speaker is Dr. Roy from the University of North Carolina Water Institute. And Dr. Roy's research team worked with Flint residents to help uncover the Flint water crisis.
Great. Can you see my screen?
Yes.
Perfect. Thank you so much. I'll add, I met, first off, Vicky and Dick, thank you so much for all the background and great work. I'm a big fan of the research paper that Dr. Sadler wrote with Dr. Hannah Tisha. So it's an amazing paper, everyone should read it. Anyway, I have with about 15 minutes, so I'll try and offer kind of, a high-level view of what happened and why, but also hone in on specific health outcomes and that we looked at in terms of kids being lead exposed, in terms of pregnant women potentially having miscarriages and so on. So a lot to cover, but I'll be brief. And there's so much that has happened in the last 7 years, 8 years. So I might miss a lot. So if you think, oh, there was something that wasn't said, just know that I probably know it, and we can discuss that during Q&A. Here's a list of papers in case everything else I talk about today is in these papers. So feel free to go back and look at them if you need to. Okay, very quickly, a simple primer on lead in drinking water. There's typically no lead in the water that leaves the plant, but the water can pick up lead through these lead pipes or these, lead in your indoor plumbing, so lead in brass fittings or lead in solder, which is sort of a glue that is used to hold pipes together. And since most of the US was especially older cities, were built in the late 1800s, 1900s. There's about 6 to 10 million of these lead pipes still in the ground. So every major US city has them: Flint, DC, Detroit, New Orleans, Chicago. And we know lead is a neurotoxin and it causes lots of health damages, but at the time it felt like the right thing because it was malleable and it was cheap and it would last you centuries, except it might hurt you pretty badly. And Vicky talked a lot about the background on what happened in April 2014. I will not go into every aspect of it except the water switch in April 2014 was done to essentially save money. People complained of health problems, rashes, hair falling out, water turned smelly. With the boil water advisories you heard about, and residents were protesting right from the get-go as these problems started to emerge, and the city and state officials kept insisting that the water was safe to drink. So what had happened, and you heard about this, when the switch happened to the local Flint River, the Michigan Department of Environmental Quality did not add federally mandated corrosion control chemicals to ensure that the lead stays on the pipe and does not come off. In addition, the Flint River water was highly corrosive. High levels of chloride, road salt application over the years in colder cities has increased chloride levels in our freshwater sources, and they can cause increased corrosion rates in our pipe systems. And so here are actual photos of pipes that we procured from a couple of homes in Flint that give you a sense of the corrosion that was going on within the pipes. A lot of technical aspects here, but just to show you that the chloride levels, the salt levels went way up, and there was no inhibitor, which again, you're required to, by federal law, to ensure that lead stays on the pipes and does not leach indiscriminately into water. In February 2015, I believe, Leanne Walters, who is now a Flint whistleblower and worked with an EPA official to test her water, found out that lead levels at her tap were very, like, astronomically high. The average was 2,000 parts per billion. Anything above 5 or 10, we start to get really worried. And her levels, kind of showed that not only one of her twins had elevated blood lead, but these lead levels were very concerning because of the lack of corrosion control at the tap. There was an unprecedented citizen science collaboration that I watched in awe, watching students and faculty at Virginia Tech work around the clock to test the water alongside Flint residents who worked equally hard, if not more, recruiting residents across the city. This was an unprecedented citizen science collaboration that showed that the water was contaminated against official pronouncements that the water met all state and federal standards, which it didn't. So this was essentially an asymmetrical science war waged by unethical government agencies, in which we viewed our job as students and engineers to provide a balance of power and evidence to substantiate what the residents have been complaining about and saying all along. And indeed, about 90% of kids came back in, I think, 4 weeks. The EPA whistleblower who worked with Leanne was silenced by EPA, and he couldn't talk to anyone for a long time. So this data came out in real time on the internet, kind of pushing everyone to pay attention and hopefully take action. And it was around the same time that Dr. Monahan Atisha did her press conference to show that blood lead levels had essentially doubled after the switch. We were doing a whole host of other water quality testing to get a sense of what else could be going on in the water. But those two lines of evidence and dogged efforts by activists and residents kind of convinced agencies to take action, and Michigan acknowledged the crisis, and Flint switched back to its original source in October of 2015 and increased their corrosion control dose to kind of speed up the healing, if you will, up to some degree of the pipes. And so it was essentially America's and water industry's wake-up call that for 18 months, residents were exposed to unsafe water in a city that, as Vicky said, over 40% below the poverty line, some of the highest water bills in the world. At least 13 people died, if not more, from Legionnaires' disease. So since then, there was a federal emergency declared, criminal indictments have happened, and there's a whole political mess about what's going on with that. And over $1.2 billion have been made available to residents for everything from bottled water filters, healthcare, nutrition replacement of all lead pipes. Now, one question you could be asking is, how could the state and the city insist that the water was meeting standards? Well, because of how they were testing. Until the August 2015 citywide sampling led by Flint residents in Virginia Tech, we couldn't rely on their official tests for a variety of reasons. For example, they asked homeowners to flush the night before you took a sample in the morning. They used small mouth bottles. So if you're taking a sample at full flow, if there are lead particles, you could miss them and you would artificially lower the amount of lead that you would measure. Less than half the homes they sampled were homes with lead pipes when you're federally required to ensure 50% of homes have a documented lead service line. And despite all of this, they still failed the lead and copper rule with the samples they'd taken. So then they decided to drop 2 high lead samples, essentially converting an F grade to an A grade and claim the water was fine. So this not knowing of what happened right from the switch until the first proper citywide sampling in August 2015, these 16 months of not knowing has led to significant angst and debate about what happened. And so we tried to answer that question, and we went a different route. So we looked at wastewater. Now, wastewater-based EPI is this amazing growing field, and it is used for monitoring everything from antibiotic-resistant genes to pharmaceuticals to illicit drugs. And I'm sure many of you have looked at research of how they're tracking SARS-CoV-2 during COVID in wastewater. So we decided to look at metals in wastewater. And we got that for 5 metals that are essentially released from domestic plumbing. We requested and received blood lead data from Hurley Medical Center for young children in Flint. And then we also had, the first sampling round and 4 more sampling rounds in 2016 and 17 of water in the same homes. So we had a comprehensive water data set for all these 5 metals too. And for the sewage and the blood lead data set, we went back all the way to 2011 to get a sense of exposure through this method. So I'll walk you through what we did. We split the time period into like the 3 years before the crisis when Flint was in Detroit water, the 18 months of the crisis with high chloride, no orthophosphate corrosion control, the actual time period of the crisis, and then 4 years post the crisis when you switch back to Detroit water, you more than triple the corrosion control dose of orthophosphate. Plus, no one is obviously, very likely, very few people are drinking the water. Everybody is on bottled water and filters. So what do we find? So on the x-axis you have time, on the y-axis, the blue dots are lead in sewage sludge or biosolid. It's a monthly sample. And the beauty of sewage or biosolids data in Flint is the majority of wastewater in Flint is domestic, so there's barely any industrial sources. And so it's a pretty reliable way of measuring all the lead that was being released through the taps, corroding through the pipes and indoor plumbing and going into wastewater. So the blue circles are monthly leaded biosolids, and the golden or the yellow diamonds are elevated blood lead in children. And the highlighted area is the actual time period of the crisis. So what you see is right after the switch, you see a huge jump in lead in biosolids and also lead in children's blood, but it drops thereafter for the remaining period of the crisis. And if you look back in the 2011 period all the way on the left, you see much higher levels of lead in biosolids and in children's blood during the summer of 2011, 3 years before the crisis, when Flint was still on Detroit water and had corrosion control. When we compared lead in biosolids to the lead in water levels that we collected through the 5 sampling rounds, there was a strong correlation. And so this allowed us essentially to take all the lead in biosolids data over the past decade and recreate what water lead levels would have looked like through that time period. And here's what we find. So again, on the x-axis, you have time. On the y-axis, you have lead in water levels. And what you see is immediately following the switch, well, maybe a month later, which is also what you heard Dr. Sadler say in terms of when the exposure goes up in children's blood lead levels, there's about a 3-month period where you see a huge spike in lead in water and lead in children's blood, and then it drops thereafter, despite staying above the action level, despite that is still, that's still in violation of federal law. So this gives us a sense of what kind of exposure or what kind of lead levels we were seeing on a system-wide level in Flint. And if you then go back in time in 2011, you see a much worse spike in lead in water and also in lead in children's blood, which again, when Flint was on Detroit's water and had corrosion control. So we have ideas on what could have happened, but but we can deal with that during Q&A. Looking forward, we now, because lead pipe replacements are ongoing, we try to do a calculation of what would lead levels look like on a citywide level once all lead pipes have been replaced, and we estimate that there will be a total reduction of about 72 to 84% of lead that you see at the tap compared to pre-crisis in 2013, which is fantastic. This gives us, the good news that as cities nationwide consider ways to, address lead by enhancing corrosion control treatment, by replacing lead pipes, we see in the example of Flint a good example of what we should be following. We also find that lead in biosolids, in lead in water and lead in children's blood are currently at historic lows after all these measures have been taken. And so I think the biosolids is an amazing new way of analyzing many of these questions about population level exposure by using wastewater. So obviously things, Flint's water quality has improved dramatically over the last few years and has been meeting standards for at least 6. And we have a nationwide reckoning of how pervasive the problem is, what should we be doing about it. And there's now a $1 trillion infrastructure bill trying to fix this issue. There's other money looking at environmental justice communities and so on and so forth. I realize time is short, so I'll skip the fetal death analysis. But what I'll end on is kind of give you a sense of, for this disaster group, when you're looking at man-made crises, especially water infrastructure, what should you be looking at in terms of problems as you're trying to, obviously there are historical problems like aging water infrastructure and lack of investment, which is what you heard, Vicky and Dick talk about. That is, again, you cannot have a crisis without lead pipes, right, in this case. But you also have the issue of how corrosive the water is. Is it being treated properly? Is it being tested properly, which we found in Flint's case. In many other cities, it was still going on. They were not testing appropriately. The fact that the lead and copper rule is imperfect and it's not enforced. And so if you have regulations that are not being enforced, how will you protect public health? There's the case of a scientific misconduct at government agencies, in this case, MDEQ engineers and scientists who oversaw the switch, did not add corrosion control, and lied about it to EPA. And EPA, on the other hand, did not intervene when they should have, way early on when they knew about what was going on. The lack of public education on our part, and also the regulatory agencies' part about all these issues. And in the intervening years after the crisis came to light, there have been significant examples of misinformation and bad science. And one paper I think you all read talked about the actor Mark Ruffalo and his antics in Flint and scaring residents, and so on and so forth. So there's this holistic approach to looking at contamination events, and you have to be kind of look at the 30,000-foot view to see it all, but also kind of then hone in on all these individual aspects and then try to solve each of them to the best of your ability to make sure something like this does not happen again. So I'll stop here, and I think we have time for questions.